You're like a bird. You're looking right down in the water, and there's a bug sitting there. And this is a lake that's perfectly smooth. But now what the bug starts to do is the bug starts to jiggle up and down. And when that bug jiggles up and down, that bug is a vibration, yeah?
Right.
And that's vibrating on a nice surface, yeah?
Right.
We're going to make what? Begin with a W.
Ripples.
All right, all right. We're going to make waves, gang. We're going to make waves, okay? And the waves kind of look like this. Where I draw the line, that represents like the crest of a wave, like it might sort of be like this. You kind of see what I'm saying? Okay, so this represents the crest of the waves. And the waves go out in all directions. And the fact that they're circles is kind of evidence that they go out in all directions at the same speed. Isn't that true? Like if it went faster over here, then the wave would sort of be like that, yeah? Okay. So the circles are evidence of the same speed. Okay. Now, what would be the frequency of the waves compared to the frequency of the vibrating bug? In other words, if you put your hand here, blip, 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 the waves would hit your hand, yeah? Certain frequency. How would that blip, blip, blip compared to the whoop, whoop, whoop of the bug?
Same.
Same. Isn't that right? The frequency of a wave is the same as the frequency of the vibrating source. Makes sense, doesn't it? Let's suppose now that the bug swims in this direction. What the bug is going to do is the bug is going to swim in the direction of the waves that it's producing. And it continues to vibrate a little bit, yeah? Wouldn't the wave pattern look something like this? Can you kind of be seeing that? In fact, what direction would the bugs be swimming, gang? I mean, you can tell it's going that way, right? Well, the bug might be at rest and the water's going this way. I mean, motion is relative anyway, yeah? Okay. Now, if I put my hand over here, would I get a higher speed wave, a lower speed wave, or the same speed wave? Check your neighbor. And make sure you're listening to the question that's being asked. How many people say, hey, the speed of the wave is going to be the same? Yeah, that's right. The speed of the wave doesn't change. What does change, gang? How frequently that wave encounters you is different, yeah? So I can get a different frequency. When I put my hand here, higher frequency or lower? Can you see it? Blip, 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 blip. Over here. Bloop, 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 bloop. That change in frequency due to motion of the source or the receiver is what we call the, named after a person. Okay, good. It is called it's a Doppler effect. That's right. The Doppler effect is the change of frequency when something moves toward you, away from you, that sort of thing. The change of frequency due to motion